Welcome, everyone. My name is Brittany Todd. I am a member of the Fabric Leadership Team. Thank you all for joining us today for Mastering Fabric Tips and Tricks webinar series led by Paul Ruth on the topic of network interfaces. Next slide, please. Before we begin, I would like to share a few housekeeping items. The webinar will include a live question and answer session following the presentation. Please note that the chat feature has been disabled. If at any point you have a question, please type it into the Q&A box at the bottom of your screen, and we'll answer it during the Q&A session. Last, this webinar is being recorded and will be shared with all registrants. Next slide, please. We are joined today by our presenter, Paul Ruth. Paul Ruth is the lead principal investigator of Fabric. He has extensive experience with Tailscale, a secure network infrastructure service, and is adept at setting up experiments in various test beds. I will now pass to Paul to start the presentation.
Hello. Yep, I'm Paul Ruth, and I will be talking to you today about all the different network services that Fabric offers, including a few new ones that even the experienced users probably don't know about yet. The roadmap for today, I'm going to go over just a review of the how networking works on Fabric. Some people have a little bit of confusion on a few things, so if you're newer, this might be helpful. If you've been around a while, this might be old hat. Then I'm going to talk a bit about a lot of the existing network services, many of which you've probably used, some of which you might not have, or maybe I'll present a new feature of it or present it in a new way that you might learn something. And then I will talk about a couple new Fabric network services that we made available a few weeks ago. And then a demo of the new services. So the new ones are in-slice port mirroring, as well as something we're calling explicit route options, which is pretty exciting. All right, let's start with a little review of the networking on Fabric. So most of you know, this is what Fabric looks like. You've seen this map before. Fabric is a bunch of sites spread all across most of the US, but some in Europe, some in Japan, and network links that go to South America. What you can do is you can create sort of like cloud resources, virtual machines with smart NICs and compute and FPGAs and GPUs and NVMe drives and P4 switches. And you can put these in any of these sites, and you can connect them together using the dedicated optical networks that we also have available here. And you, of course, the special power here, one of the special powers is we can connect to all the real things you already use, including the public clouds, the various other test beds that you might be using, and different supercomputing facilities that are academic supercomputing facilities around the country or the world, really. So the key thing, the way to think about Fabric is that it's kind of like a cloud, where it's like a bunch of clouds where you can get regular compute kind of cloud things in a lot of places. But you can also do this network. They have the special networks that connect everything together. And the way you get a cloud resource in the public clouds or in Fabric is you create a virtual machine, you might have special components in it. And the way you get the special networking services from Fabric is you deploy something that we call a Fabric network service. So think of Fabric network services kind of like virtual machines, but for the networking part of the Fabric cloud. As many of you know, so this is a review of the Fabric networking. Just to be clear that we know what we're talking about here. There's a management plane that you get with your virtual machines, and then there's a data plane. And this is really a key to understand, and some people confuse this a little bit. So I'm going to go over it and make sure we all understand. So when you create a VM on Fabric, you get the Fabric, you get the management network, and you have a VM connected to the management network, and there's an interface inside your virtual machine connected to the management network. And using this interface, you can access the public internet from your virtual machine. Now this management network, it has a public IP address, either IPv4 or IPv6. You don't get to choose. It's decided based on what site you're on and what kind of IP addresses were available to Fabric at that particular site. It's also intended for management of your experiment. So this is for SSHing into your node to control your experiment, to configure the VMs, to monitor what's going on in the experiment. That's what it's for. You're not really supposed to use this for your experiment. And of course, as for this reason, we're trying to protect the experimental part of the network. So the management network, it actually blocks internet-facing services. So the only way to get in, as many of you know, is through the Bastion host. So you can connect your external machine, your laptop, your Jupyter Hub to the public internet, which is connected to the Fabric Bastion host. And then you can jump through the Bastion host to get into your virtual machine. And that's the only way to get in. So you can't actually put services on the management part of the network. Now, and this is for good reason. So this is so external attackers can't get into either the management network or the Bastion host and interfere with your experiments. And this is what, and you want this though. And the reason you want this is that now your data plane is isolated from the public internet, and you can do whatever really disruptive thing you want in this sandbox. You can do really risky things. You can do things where you don't care about security at all. You can just do whatever you want, and it's safe and protected from the public internet. And the other thing that you can do here on the data plane is you can deploy these network services that we're talking about. So this is where you can deploy your dedicated layer 2 networks, the layer 3 services, the new port mirroring, the explicit route objects, and a few other things that you probably know how to do it. And this is like really important, that this is where you can kind of control all the network and do whatever you want, but it's isolated from the public internet. Okay, so that's all stuff that you probably already know if you're an experienced Fabric user, but I just want to be clear that when we're talking about network services, we're talking about the data plane networks and the different features you can deploy inside the data plane. Okay, so data plane network services, there's probably a bunch that you're familiar with, and there's some that are new. So here's a list of like most of the network services that you're going to use, including the new ones that I'm talking about. So they're vaguely broken up into layer 2 services. So these are Ethernet. There's a bunch of different ways you can do Ethernet, local networks, wide area networks, multiple devices connected to networks. There's also facility ports. These are they're Ethernets that can connect straight to the external facilities that you might use. And we'll talk about those in a minute. And then the other main category is layer 3 services. So this is actually Fabric providing its own internet, but the internet is inside the data plane, inside the protective sandbox that is Fabric. So you can use this layer 3 internet to connect all of the pieces of your experiment across an internet, but this internet is sandboxed and protected from the evils of the outside, and you can be a little bit more risky and do a little bit more disruptive things, and you're just free to experiment, right? The layer 3 services, they come in a couple flavors, the IPv4 flavors and IPv6 flavors, and they both actually have an extension which actually allows that data plane to peer with the public internet, and I'll mention that briefly in a minute. But that's kind of for very special cases. So generally speaking, your layer 3 internet inside of the data plane is isolated from the external facility or external internet. And for today, like some of the most important part of what we're going to talk about today are some new specialized services that we've just deployed. One of them is called ERO, or explicit route options. And this is like a layer 2 point-to-point network, except you get to specify the path it takes through Fabric, which is really cool. And there's a port mirroring, and port mirroring comes in a couple different styles. One is in-slice port mirroring, another is infrastructure port mirroring, and the in-slice version of port mirroring is new as of a few weeks ago. And I'm going to walk you through this. And what we're going to do is talk about all the different network services, and then I'm going to do a demo of both ERO and port mirroring for you. Okay, so L2 bridge, this is the most basic one. Like you've all probably used this because this is the easiest Fabric network service to use. It's a layer 2 bridge. We call it an L2 bridge. It's an isolated Ethernet that lives in one single site, and you have an unlimited number of virtual machine interfaces that you can connect to it. This is an Ethernet. It has no requirements about what layer 3 you use. So you can control all layer 3 configuration of the network. Often people like to do really manual things where they can be as exploratory as like not using IP at all. There's some experimenters that do that. Most of the time, users want to put IP addresses on their layer 2 network, and sometimes you want to do it. You want to manually do it yourself, which is really you can do that. That's an option. But also we have FabLib, which has some service tools that will help automate this process. And we recommend people use that for like if you're getting started, or if you just don't have very specific preferences of how the layer 3 services go, you should just use the FabLib automated tools. And generally the purpose for this is to have connectivity between VMs within one site, but with full control over the layer 3 configuration. And that's what people use it for. The next one is a step more advanced. This is layer 2 point-to-point or L2 P2P. This is similar to L2 bridges, except this is a circuit that connects exactly 2 interfaces on 2 virtual machines, and those virtual machines are on different sites. So this is a point-to-point network service that goes across Fabric from one site in Fabric to another, ending on exactly one virtual machine interface that in your slide. So the cool thing about this, exactly 2 endpoints, goes across the wide area. Eventually, this will be the service that has quality of service. So if you want to have guaranteed bandwidth across Fabric, you'll have to use the L2 point-to-point. That's not quite ready yet, but it will be soon. Just like L2 bridges, you get full control over the L3 configuration. You can make it manual, you can use FabLib automation, or you can not use IP at all if you don't want. You can do anything you want, user specified. The purpose of this, so this is Ethernet connectivity between a pair of VMs on different sites. A lot of times experimenters do this if they're deploying virtualized routers or switches spread out across Fabric, and you want to have control over the layer 3. So you want to actually run your own routers or run your own switches. You can connect VMs together using L2 point-to-point services, and then you can route traffic through your experimental topology. One interesting thing to note here, and this will come up later when we start talking about ERO, is like when you make this connection between 2 VMs on 2 different sites in Fabric, it goes through the Fabric dedicated optical network, but you don't get to choose what path it takes. It just goes through in any which way Fabric chose it to go through, and you just don't even know. So like, what path does it actually take? The answer is you don't know, and you don't have any control over it. So, but keep this in mind for later when we talk about ERO, because we have an answer to this question. And lastly, the L2 site-to-site service is also an L2 service. So this looks like an Ethernet. It looks like an Ethernet switch. The difference here is this is a circuit that goes between 2 bridges, one on each of 2 sites, and it has to be exactly 2 bridges, exactly 2 sites, and you can connect as many VMs to it as you want. And generally speaking, this looks a lot like having one switch that spans 2 sites, although it's really 2 bridges with a circuit between them. And the purpose is to have pretty easy Ethernet connectivity between many VMs on different sites, and you still want full control over the L3 configuration. So you can still do routing over this, but routing is often done with the point-to-point links, but this is a little bit more flexible. You can do a few more things with it by adding extra VMs on the links. And notable that this will never be able to have quality of service guarantees across a site-to-site service. So when we do finally have quality of service guarantees, they will only be on the point-to-point services. So the FabNet networks, this is actually maybe some of the easiest networks to use. Because with the FabNet networks, you actually are going to be connecting to Fabric's internet. So this kind of feels a lot more like when you're connecting to an internet, like at your house, or like you get on the Wi-Fi at the airport or a coffee shop or whatever, or what have you. In this case, when you have a FabNet v4 or v6 service, you'll be issued a local bridge that you can use to connect your VMs to. And that bridge will have included with it a subnet that is allocated to you and a router with an IP that is the gateway to the rest of the network. So this is just like you show up at a coffee shop, you open up your laptop, there's a subnet that the coffee shop has, created there, and you get issued an IP, and you set the router to the right router, and now you can connect to the internet. The only difference here is you control the whole coffee shop's network, and you get a layer 2 bridge, which is the entire network. You get issued a subnet, and now you have a gateway that you can configure your routes to, and then you can route to the Fabric's forwarding the internet that is across Fabric. Couple things to know about this. You get what's interesting here is that when you create one of these, the network service is actually one network service per site. So in this picture, we actually have two FabNet v4 or the FabNet v4 network services. One is this bridge and this router on site 1, and one is this bridge and this router on site 2. And if you configure the routes correctly, then you can have the VMs connect to each other. And that is that will work even if even if the FabNet networks are in separate slices, or even if they're owned by different users. So this is just a way, kind of like the analogy of at the coffee shop, you get connected to the internet. Here, you can take your VMs and connect it to Fabric's internet, and you can talk to anyone else that is already connected to Fabric's internet. And that's kind of the power of it. So you can actually provide services to other slices or other users or other parts of your slice across this network, while still being protected from the public internet in the sandbox. Purpose of this connection between VMs on different sites where you don't actually care about the low-level networking. And yeah, you just don't care about the low-level networking. So this is what it's for. There's an extension to this that I mentioned called FabNet v4 EXT and FabNet v6 EXT. But I forgot to mention that the FabNet comes in, you can either do the IPv4 version or the IPv6 version. So if you want to experiment with IPv6, this is a good place to do it. You can just turn on FabNet v6, and then you can kind of experiment with how does IPv6 work. So that's a value here. Yeah, and so the extension to this that a lot of people want to use is the FabNet v4 EXT and FabNet v6 EXT. And what this is a peering between routes between your subnet and routes to the actual public internet. This is only necessary in very rare cases where you have to do an experiment that needs to connect to something on the public internet and it can't do it over the management network. There are very few cases that we found that require this. The one thing that we require of you, if you have a need for this, we want you to be able to maintain production level security across these links so that we can maintain the isolation between the public internet and the experimental sandbox. And so if you want to have FabNet v4 or v6 EXT, we'll want to talk to you about that and make sure you have the right security in place and you have the right controls. So that'll be, it requires an extra authorization, and it'll only be authorized in really special cases. Facility ports, some of you have used these before. So these are layer 2 connections from stuff inside of Fabric to stuff outside of Fabric. These are isolated layer 2 networks that you own. What a lot of people use these for is to connect to other test beds. Like you can connect to Chameleon and Cloud Lab and the Open Cloud test bed as well, using facility ports. You can also connect to the public cloud, so Amazon, Azure, Google Cloud, as well as many users have worked with us to set up the ability to connect straight into your institution or campus or your collaborator's institution or campus. And that is also available and in a really good way to include all the real facilities and instruments and institutions that you already use, include them in your isolated experimental sandbox that goes across Fabric. So this is what you can do with that. So the purpose of this is to get realistic experiments at geographic scale, connected to real external facilities. And many of these are actually test beds that you also use, like Chameleon and Cloud Lab. All right. Where are we? Okay. ERO service. Okay, this is one of the new ones. So this is like one of the ones I'm pretty excited to share. So ERO it stands for explicit route options. This is really similar to L2PTP. So this is a point-to-point link between two VMs that are in different sites within Fabric. The interesting the piece though that is a bonus here is you actually get to choose the route through the network. So like with a regular point-to-point link, you just have this and you have no idea what route it goes through. But if you use the explicit route objects, you can actually pick the hops it takes through the Fabric network. So in this case, it looks like it's Seattle, and Los Angeles, or Dallas, Atlanta, and New York, or something. And that's the path that your L2PTP service will take through it. So this is really cool. The purpose of this, which is really exciting, is you have connections on different places, but now you can control the path. So a couple of things. You can maybe extend, choose the latencies that you have between your sites. So you can artificially make the path longer or shorter. And you can also do things like have multiple paths, some of which have maybe more bandwidth or more latency than others. And you can have things in your experiment that choose which path to use for different purposes. And things like that. So this is really about controlling the path and controlling latency. And in this picture, I have a nice little straight path, but like you can do all sorts of crazy things and make the path go all sorts of different ways. There's some limitations because the underlying technologies don't allow all the different paths that you might dream up, but anything that seems kind of sane and regular should be possible. So, and I'm going to show you how to do this in this. So here you can actually take a path and make it artificially longer, bounce it off of Hawaii and then over to Europe and so forth. So this is really exciting what we're going to do here, or what I'm going to show you in a minute. Port mirroring service. So port mirroring, this is also a new one. So it's actually not fully new. We've had a port mirroring service. This is in-slice port mirroring that will be available to all users or most users. And then what this is if you've ever used a real switch and you set up port mirroring on it, it's exactly what it sounds like. So if you have a network, let's call it, say, an L2 bridge, it's not limited to an L2 bridge. You can do it on a site-to-site link or an L2 bridge. And what you can do now is, like, if you have traffic that is going through it through your L2 bridge between your two virtual machines, what you might want to do is look at that traffic and see what's going on from a third point of view. So like sometimes this might be a simulation of, like, you have some experiment going on that's looking at security, and you want to have somebody eavesdropping on the traffic and looking for different security incidents or anomalies. Also, the other thing could be you're just wanting to monitor your experiment and see what your experiment's doing, but you want to do it sort of out of band. So the way you would do it normally, like today, the way without port mirroring, is you'd probably run a little service inside of one of your VMs, but now you have a service that is consuming resources in your VM in order to monitor the experiment. And that might actually interfere with the performance of the experiment or have some overly complicated configuration. So what we can do now is you can add a third VM here that's a listener VM connected to the same L2 bridge. And then you can instruct the bridge to mirror traffic that is either transmitted or received from a specific port. So in this case, this VM on the left has traffic going in and out of it from the other VM, or sorry, the VM on the right has traffic going to and from it from the VM on the left. And what we've told the bridge to do, or the switch to do, is to make a copy of that traffic and send it to the listener VM. So now any traffic going either in or out of the right VM will also be sent to the listener VM, and the listener VM can now do analysis of it or record it or whatever you want. And the really great thing here is it doesn't interfere with the performance or any of the bits that are going back and forth between the two main VMs. So you can do this out of band in a separate way. And I'm going to show you how to do that in a minute. some of you might know that we've had for a while infrastructure level port mirroring. And this is a little bit different than what we're talking about here. So the infrastructure level port mirroring mirrors traffic to one of your VMs from an infrastructure port on Fabric's underlying data plane, underlying network switches. And this is kind of a different thing because this is the people that are doing this are doing it to actually study the traffic going across the Fabric networks, just to see like how people are using it and like if they can see anything in the traffic. And there's only a couple people that are allowed to do that. If you have a use case, we're open to it, but we want to like make sure you're going to use it for good things and not just eavesdrop on everybody. So there's only like a couple of people that are allowed to do it, but this regular in-slice port mirroring will be available to everybody, so you can monitor your own experiments. All right, cool. And I got enough time that I can show you the demos. All right. So here we're going to go to the demos. Bring this over here. Make sure this works. So just like every other demo you've probably seen us do, these are all going to be in the Jupyter Hub. This is my pre-baked secret answer slices over here in case I can pull them up when I need it. But if you've been to the Fabric Jupyter Hub, you know that we have this this index that has a whole bunch of example of using Fabric for all sorts of things. What I'm going to go through here is a couple of the networking ones, and you can see here there's this port mirroring example that has both the infrastructure and an in-slice. So we're going to go over the in-slice port mirroring example, and then also we're going to go through, if you look at the wide area layer 2 links. This last one is called explicit routes now, and we're going to go over, I'm going to show you how the explicit route options work. Okay, so let's start here. I'm going to open up the in-slice port mirroring example. And this looks like a lot of the notebooks that you've seen before. Let me just restart this to make sure it's started from scratch. I'm going to go ahead and run this so we can get. Here we are. Okay, so the start of this is just like you've seen most of the time. We just kind of import the Fablib manager and show the configuration to make sure that it's sane. We come down here, we have some examples here, or some names here. So this is going to name the slice, and we have a node 1 and a node 2, and name the networks. We're going to name the node the listener node, and then we're going to specify that we want to mirror the traffic in both directions. You could also choose just the receive direction or just the transmitted directions, but in this case, we're going to look for both of the directions. Then we're going to do this where it's going to actually get some random site, get a random site, but it's going to make sure it has at least 2 ConnectX-5 dedicated NICs on it. So for now, the port mirroring works on the dedicated NICs. I've been told that we're going to be able to make it work on the basic NICs as well, but that doesn't work quite yet. So for now, if you want to do the port mirroring, you have to have the dedicated NICs. So this is so one of the other things I want to show you today is a bunch of little tricks that we all use to kind of simplify the use of Fabric in general. So this is an interesting way where you can actually get a random site, but you can specify that the random site has some properties available. So in this case, we're asking for a site that has at least 2 ConnectX-5s available, and hopefully it's going to find it for us. And then you're going to get another site, but this site is going to be any site. It doesn't matter because we're going to use a basic NIC, but we just want to avoid site 1. So we just want to make it so that it's not the site that we had used before. So what we're going to end up with is 2 VMs on 2 different sites, and we're going to set them up. So here we got Michigan and Indiana. Those are not particularly interesting. Well, it's fine for port mirroring. It would be not interesting if we're doing explicit route objects because they're too close together. And then we go ahead and just run this here. So what we're going to show you here is we're going to create the slice, and the slice is just has the name of the slice, and then we're going to create 2 layer 3 networks. So these are both IPv4 networks. These are FabNet v4 networks. We're going to create two of them. They're totally separate networks. One is going to be on the Michigan site, and one is on the site in Indianapolis, or in Indiana. And these will be in our network. We're going to put one VM on each of them, and then configure them to be able to send traffic to each other. So if you haven't experimented with this yet, here is a really simple way to automatically have you Fablib configure those networks for you. So in this case, we're going to, we created the network at one of the sites. We're going to add a node to that site. And we're going to add a component to that site. And then we're going to set that interface mode to automatic. And then we're going to add that interface to the network that we had created previously. And then we're going to add a route to that to this subnet. So this subnet is the subnet that is all of the FabNet network. So this is a way to like set a route, but set it to like anything on FabNet you want to route through this network. And then you're going to use the gateway that you got from the network. So here, this is the when I say on a FabNet network that you get issued a subnet and a gateway, this is how you can get this is the gateway right here, and this subnet will actually be used by the the automatic configuration to configure it. So in this case, this is like a really simple case here where we just created two VMs, one on each of two sites, both connected to FabNet, and we're going to wait for this to finish, and then I will show you the rest of it. I was hoping this would go a little faster. All right, and I will show you that, like, I'll talk about this next step while the first step is still going, so that we can, keep talking, I guess. So one thing that a lot of you don't know, and this is why I wanted to do this live and not just use my pre-baked version here, is that when you have a slice in Fabric, you can modify it by just changing it using the same interface and Fablib interface and tools that you used before. So what we're going to see here in a minute, once this the original slice comes up, we're going to see that we have two nodes, one in Indiana and one in Michigan, which you can see the Indiana node is up, and we're going to have two networks, one on each, and we'll be able to SSH to them and ping between them, and I'm going to do that. And then what we're going to see is we're going to come later after the first half of the slice is up and ready to go, and we're going to add the listener node. So this is not, we didn't deploy the listener node with the first two slides in the beginning. So, we didn't deploy the listener node at the beginning when we created this slice. We're going to add it later, and this is totally allowed and easy, and you can do this. And not everyone that uses Fabric knows this little trick. It's not even really a trick; it's just a thing that it does. So here, while we're waiting for this to come up, I'm going to start up some terminals and put them over here on the side. So we can start logging into these VMs, and I can show you what this is going to do. And hopefully it works. All right, so if you look here, okay, so now we have our two nodes are up, one in Michigan and one in Indianapolis. And now the post-boot config is happening, and this is actually doing that automatic configuration of the addresses. And you can see that it's now done. So what I can do now, I can log into each of these machines. And you should be able to see, if I do IP address list, you can see that these machines have the management interface, and then they have their dedicated ConnectX-5 card that has 2 ports on it. And one of those cards is configured with this particular IP address. You can do IP address list over here. And you can see that this one also has, this one actually only has 2 interfaces. It has its management interface, and then it has its one basic NIC interface that has only one interface on it. And it is also configured with a FabNet v4 address that was allocated. And you can see the subnets here for the two different sites. So this is 10.131.3 slash or .0/24, and you can see that that corresponds to this subnet here, and this IP address is number 2 of the list, where the gateway is number 1 in this case. And this one is 10.140.1.0, and you can see that that matches up with here. So what we can do now, and I'm going to go ahead and run this, so this will get going while we're talking here. What I can do here is you can see that if I type IP route list, you can see that there's a route that goes to 10.128.0.0/10. So this route is the route to everything that's in FabNet v4. It's like any subnet that you would ever get issued on FabNet v4 is in this greater subnet, right? And then this is the local gateway that was issued to this machine. So what I can do now is I can ping from this machine. Actually, I'm going to do it from the other way. I can ping this machine from that machine, right? So ping node 1 from node 2, right? And you can see that it takes, 10 milliseconds because one's in Michigan and one's in Indiana, and those are states that are right next to each other, right? So what I can do, so we can see now, I've submitted the next part here, which I'll talk about in a minute. What I can do here is I can install. So if you wanted to look at the traffic that was going back and forth between these two machines, I need a tool that will look at traffic. So I could type sudo dnf install TCP dump, which a lot of you have probably used before. -y, whoops, I spelled it wrong. And this is going to install TCP dump on node 1. And meanwhile, node 2 is pinging. I will stop it for now. So now what I can do on node 1 here is I can do sudo TCP dump -I. I have to actually figure out what the address is. Let me see. IP address list as a TCP dump -I for interface, and I can pick the interface. In this case, it's ETH1. And what this will do is actually take all the packets that go in or out of ETH1, and it'll just print them out to the screen here. Whoops, I have to sudo here, sudo. So now this is printing all the packets that are going in and out of that interface. And right now there's nothing going in and out. Occasionally we might see some background ARPs and things like that if we wait long enough. Well, there's two things that are interesting about this. One is that this is isolated from the public internet. So I'm SSH'd into this machine, but I can do an experiment on this interface and there's no traffic on it except for the traffic that I forced through it. So I don't have to like filter out other traffic that is just me trying to monitor this. But if you see here now, what I can do, if I turn on this ping, I start seeing the ping traffic coming here. So you can see these ICMP echo requests, and I stop it here for a minute usually, and echo requests and echo replies, and they come in every second. And this is just the ping packets that are coming from one machine to the other. And I can see them, but I'm running a tool on the machine that is actually receiving this traffic. So if I was doing an actual experiment here, I would be interfering with my experiment to some degree. So now what I do is I come over here, you can see this is starting to become active. You can see that I can take this slice where I have these two machines that are connected to FabNet v4, and I can come down here and I can create a new node. So I'm adding a new node to the slice. I just get the slice that I'm using. I get the node 1, and then from node 1, I can get the name of the port and the name of the VLAN. So these are the VLAN and port at the lower level, and you need this in order to set up your port mirroring. And then you can see here, what I do is like add a node. I add another ConnectX-5 NIC to it. And the special thing here is I can say add a port mirror service. So this is the new port mirroring service that is actually going to tell it's gonna take the it's gonna take the listener interface, and it's here. So it's going to say like, I'm gonna name this port mirroring service. I'm gonna mirror this port and this VLAN, and I'm going to set it to send it to the interface on the new listener node I created. And I'm going to say I want it in both directions because that's the feature I had up there. So this is going to mirror the traffic on this port name and VLAN that I got from node 1. And it's going to mirror it to the listener interface that I got from the listener node that I just created. And then I'm going to say do it in both directions. So you can see now, once I submitted that, even though this slice was up before, I now have another slice that it has an additional node at Michigan. And it has an additional, port mirroring service. And it has all these other interfaces. So you can see I modified the slice live to add this interface. So now I'm not gonna, the rest of this actually shows doing the pings that I'm showing you live, but I'm just gonna show you live. So I can come over here and I'm gonna take this listener node and I'm gonna SSH into the listener node. And what you can see here is by the IP address list, you can see that this listener node has 3 interfaces. This is the management interface, and this is the ConnectX-5. But if you look carefully, there's no IP addresses on this. I didn't tell it to automatically configure any IP addresses. I haven't done it manually. I don't actually need them. So what I'm going to do here is I'm going to note that all the traffic that is going to and from node 1's interface on this network is being mirrored to this ETH1 here. So what I'm going to do, I'm going to say sudo, and I need a way to see this, right? So I can sudo dnf install TCP dump minus y. Did I spell it right? I did not spell it right. So I'm going to install TCP dump so I can see all the traffic coming in on the interface. Just trying hard. And what I'm going to be able to do once this is done okay, and now it's done. So if I do IP address list, you can see that I have my interface ETH1 with no IP address, but it is the one that is mirrored. So I can say sudo TCP dump minus I ETH1. And now what I'm doing is I'm taking every packet that's coming in and out of the listener port on the listener node, and I'm just putting it to the screen here. And what you'll notice is if I ping from this node to that node, now I can see it both from node 0, but I can see the traffic from the listener node as well. And I don't even need this one running up here. So like you can see that all of the traffic that's going back and forth between node 1 and node 2 is getting mirrored to this listener port. So now what you have here is port mirroring within your slice. And the traffic between node 1 and node 2 is unobstructed by any sort of monitoring that I'm doing in the listener node, but the listener node can see it. So this is a pretty powerful thing that you can now do in Fabric. All right, and then the rest of this example just basically does these pings like I'm doing, but it does it automated, so you can look at that if you like. All right, so I hope that's interesting. If you guys are live, I'd answer some questions now, but we're going to go to the next thing, and then we'll get to questions. So the next thing, exit out of these, I guess. Okay. I'm gonna leave that up, but I'm gonna go back over here to my start here, and I'm gonna go and we're gonna talk about explicit routes now. Okay, so I'm gonna go up explicit routes. We'll go ahead. We got 16 minutes left, so I gotta go a little fast, but I have this one already pre-baked because it takes a little while to run to set it up. So I'm gonna go ahead and run this, and then we can talk about what it's doing here. Okay, so the beginning of explicit route objects, if you remember what we're doing is we're trying to pick the path that a point-to-point link takes across Fabric. And so what we're trying to do is this. We want to pick some crazy path that goes across Fabric to connect our two VMs together. That's the goal of what we're doing right now. So the first thing we do here is we also need the ConnectX-5s here. So what we're going to pick is two sites that happen to have at least one ConnectX-5, and we're going to see which ones it gives us. And then what we're going to do is create a list of hops. So by default, it says hops equals, like, we have to put, it wants it to hop to the third random site. But what I'm going to do is manually pick them, because I want to pick an interesting set of hops. So once this pops up and tells us which sites we can go back to our Fabric map that shows all of the sites, and hopefully we can pick an interesting route. Hopefully we don't get two sites that are right next to each other, because that's kind of boring. All right. Come on, you know you want to do it. So now it's just trying to pick random sites, two random sites that happen to have ConnectX-5s available, and then it'll print off which ones we get. Sometimes this takes a little while if it's rebuilding the model in the background. Sometimes you just get the cached version that shows you. But when you're searching for ones that have enough of a specific type of resource, it has to refresh from the ground truth, like which resources are actually allocated at this time or not. And probably some of you are trying to do this at the same time, which is always makes it a little bit slower. Okay. All right. So, okay, while we wait for that, I will talk a little bit about what we're going to do in the next step. So in the next step here, what we're doing here is we create a new slice. And in this case, we're going to create two networks, two layer 2 networks. So these aren't layer 3s. Oh, wait, here we go. We got Kansas and UCSD, right? So if we want to, we can pick an interesting path between these two. So let's go back up to our portal and look here. And so we got Kansas City and UCSD. So I'm going to pick a pretty simple path. I'm going to make it more interesting than just one hop though. So I'm going to go from Kansas City to Utah to Seattle to Los Angeles. So we're going to go Utah, Seattle, Los Angeles, right? That's what we're going to choose here. And what this will do, like, if I didn't do this, it's just going to pick the shortest path. So it's either going to go Kansas City, Salt Lake, Los Angeles, UCSD, or Kansas City, Dallas, Los Angeles, UCSD. And the thing is, you don't even know which way that's going to go. It's just going to pick it based on whatever it decides is the best thing. So if we want to choose it, we're going to go Utah, Seattle, Los Angeles, UCSD. That's what I'm going to go with here. So to pick our hops, we say Utah. Got to spell everything right though. Seattle, and then Los Angeles. So we're going to set that's our hops in order, and you can make that list arbitrarily long. And then we'll just go ahead and submit that. And you'll see what we're doing here is we're adding two layer 2 networks, one of which we're going to use the Fablib like automatic IP configuration, and we're going to set it to this subnet. And we can choose any subnet we want because we picked an L2 network. And the other one, we're going to use this subnet. So they're almost the same, just, 1 and a 2. You can see here we are adding a node. We're using a ConnectX-5. And then for the one interface, we're going to set it to auto instead of VLAN 100. And the other interface, we're going to say auto and say VLAN 200. And then we're going to add the interfaces add the network. We're going to add the interfaces to the network here. And then we're going to do the same thing with node 2. And then the magic thing here is we say net1 set L2 route hops, and we're going to pass in our list of hops. So now what we're going to have is network 1 is going to use our list of hops, and network 2 is going to use whatever list of hops that the system would have chosen. And what we'll be able to see once this is done is we're able to see that the pings take different amounts of time depending on which one you chose. So I know this is going to take a minute. So while this is happening, I will open up my magic window here, and I actually have a version of this that I already ran earlier. And if we go through here, we can look at what I did. Is I actually specifically chose Washington and Hawaii to make them pretty far apart. And then I chose my hops to be New York, Starlight, Atlanta, Dallas, Los Angeles, Salt Lake City, Seattle, all the way across. So this is a huge number of hops. It took a little time to set up, but it's interesting. So remember this Washington to Hawaii, and then I go New York, Starlight, Atlanta, Dallas, and so forth. So if we look at here, it's Washington and then Hawaii, which is off the side of the map. And the path goes New York, Starlight, Atlanta, Dallas. Is that what I did? Atlanta, Dallas, Los Angeles, Salt Lake City, and then Seattle. So Dallas, Los Angeles, Salt Lake City, Seattle, and then Hawaii. So I made this big crazy link or path that goes all the way through the network. And I tried it, I ran it. You can see that it created the two machines. It created the crazy path. And then we have two networks, one called network and one called net with ERO. And then we can run the experiment, but I'm just going to go ahead and show you what it does, right? So if you just copy this, let's close this one, SSH into the node that's in Washington, node 1, and SSH into the node that is in Hawaii, which is node 2. If we look here, there's an IP address list. You can see that I have two networks here. So I have the data plane network, and then I have some ConnectX-5s. You can see that in this particular network, so I have this ConnectX-5 with two networks, and you can see here that I've added VLAN 100 on ETH1 and VLAN 200 on ETH2. It's because these are L2 point-to-points, so they have to have VLANs on them. And you can see that the first one is 192.168.1.1, and the second one is 192.168.2.2. And then there's a similar address list set up on the node that's in Hawaii, except here we got 2.1 and 1.2. So they're kind of opposite, right? So, and what we can do here is if I ping from this machine to 1.2, which I think is I think 2.1 is actually the one where the system chose the network for me. And you can see that the round trip time between Washington and Hawaii, if I just use the direct route that's like arbitrarily chosen for me, is about 121 milliseconds. And if I were to ping 1.2, this is going through the crazy path, and you can see that the round trip time is almost 200 milliseconds. So you can see here that these are actually taking two different paths through the system, and you can go back and forth between the two. And what's cool about this or interesting about this is that at layer 2, you don't usually get to choose your route or your path, because it's not a route, it's just a path through the network. But because of the way we have this explicit route options, you can actually choose your layer 2 paths through the network and get different bandwidths or latencies or what have you. Okay. All right, so demos are done. Hopefully that was exciting for you. It's difficult sometimes to give these talks and not have actual feedback with people asking questions and looking like they're interested. I can't see any of you. So the demos are done. I think we're ready to ask questions. And Chelsea maybe is going to ask questions, or Brittany.
Yeah, hi. Thank you so much, Paul, for that presentation. We are going to move to the Q&A session now. So we will start with questions that were submitted during the presentation. And Paul, if you'd like, you can stop screen sharing now. So the first question that we have is, thanks for a great demo. 2 questions regarding port mirroring. Is mirrored traffic treated specially or differently by Fabric? And the second question is, can mirror traffic be lost if the switch port is congested? Or can we prioritize mirrored traffic to avoid it being lost?
So, the traffic is not treated any differently. And we're in fact using at the lower level inside of the actual data plane switch. There is a port mirroring like configuration of the low level switch. So we're actually just using that. So like the port mirroring in your slice is no different than if you were to log into the switch and set up port mirroring. So that's what you get. It's not treated any different. There are some considerations though, and I think you're getting at like a really key thing here, is that the port that you're mirroring has ingress and egress, and that port has, like, if it's a 100 gig port, it can do 100 gigs in each direction. But now we're sending this all to this other port, which is going to consume it all, and that port only has 100 gigs. So if you're doing 200 gigs of traffic in both directions and you're trying to mirror that, it won't fit in the port you're trying to target, and you're going to lose traffic. If you're using bandwidth like that, then you're going to have to consider optimizing which packets you mirror and things like this. If you're doing something smaller, you'll probably be okay, and it'll just mirror everything.
All right, great, thank you. The next question is, when I create network services, how can I add IP addresses and routes to the VMs?
Well, okay, so I did show in the example, the examples I'll use some of the FabLib automated services, mostly because what I'm showing is not really how to configure the addresses. I just want to like use the network. And for a lot of experiments, you also want just to use the network. You don't really care about configuring it manually. So I would suggest, unless you know you need to manually configure something, just use some of the FabLib tools that automatically do it. But if you have some really specific configuration you want, you can log in with SSH and configure it manually yourself by typing it, or you can use the FabLib's execute function, and you can just have your script execute different commands on the node to configure it however you wish. So that's kind of how I do it. I like to try to use the FabLib tools as much as possible. In fact, originally I wrote some of the FabLib tools because I got tired of logging into the nodes all the time and configuring them. So I just wanted some easy tool to make my life easier. So that's what they're there for. Use them if you like. Yeah.
And so there's a follow-up question, which is, why do IPs get unconfigured when I reboot a VM?
Yeah, so this is something that we get a lot of questions about too. So a lot of people want their VMs, once they configure them, if they reboot the machine, or if the host goes down and then the machine has to come back and the VM has to come back, a lot of their configuration is gone. This is really no different than if you just had a machine that you configured yourself. Like if you bought a machine from Dell and put it on your desk and configured it. There are ways to configure it where it's just temporary for this particular execution, and when you reboot it's gone. And there's other ways to make it persistent through a reboot. A lot of these things that have to do with poking the configuration scripts that run on startup and making that work. It's really up to you. The FabLib tools that the helper functions that do it like really easily don't actually poke the startup scripts. So if you wanted to last through a reboot, you're gonna have to like go in and like configure it as if it was a real machine that you're really trying to manage. So that's that.
Thank you. And the next question is, can I use ERO to make a path that loops around the supercore several times?
So this is something that a lot of people want to do because if you could do this, you could make arbitrary long latencies. So for now, like the latencies from one end of Fabric to the other, like the biggest ones I've seen, like maybe about 300 milliseconds. If you choose a particularly bad path and go from Europe to Japan, you can make that happen. Because of the underlying technology that we're using to do ERO, the path that you're taking can't go back to the same switch twice. That's the rule. And so no, you cannot make a loop that goes around many times, because then you'll have to go to the same switches multiple times, and you can't go back to the same switch type twice. a follow-up answer to this, which is a little bit tricky, is that when you are doing a hop in the middle using ERO, you don't have to choose like the next hop along your path every time. You can choose just one in the middle. And if you do that, the system will choose the best path from the start to the middle, and then from the middle to the end, even if that goes through a couple other switches. And that's great, and that makes it easy to do some of this hop stuff. But you have to make sure that even when the system is picking the path for the subsegments, that you never hit the same switch twice, because it won't let you do that. That's basically the requirement with ERO, is if you hit the same switch twice, it'll error out. But anything that's sane and reasonable, it should do.
All right, great. And that was actually our last question. So I want to give one more thank you to our speaker, Paul Ruth. And also, in addition to our presenter, we would like to acknowledge the behind the scenes team. They are going to be listed on the screen here, and they've worked diligently to bring this webinar to production. So thank you so much. And also thank you to the audience for your participation in today's webinar. In addition to a recording of this webinar, we will also be emailing everyone who has registered a list of resources. So this slide deck will be shared along with our connect with us form. And we hope that you will reach out to the Fabric team for any questions or support that you may need. We have some other webinars that are coming up next month. So 2 of them. The first is Mastering Fabric Tips and Trick webinar series. And it's going to be on Monday, September 16th at 3 p.m. Eastern. And then the second one is Stitching Together Innovation with Fabric Users on Tuesday, September 17th at 2 p.m. Eastern. The September 16th webinar is geared towards existing users, and then the September 17th webinar is geared towards new users. So we would appreciate it if you could forward the information to any of the relevant users in your community. As a final reminder, please submit your Fabric matrix and make sure your project abstract in the portal is up to date as well, because we use that information for outreach, including our website. Thank you again, and have a wonderful day, everyone.